The last lecture was all about the scientists and how we found out about atoms and the parts to the atom. An atom is the smallest particle of an element that can retain the chemical properties of that element. If you go smaller than an atom, you do not have that atom anymore. So you have an atom of a certain element, you go smaller than that, you don't have that element anymore, you have its parts. For example, if you have oxygen, if I go smaller than oxygen, I don't have oxygen anymore. I would have the protons of oxygen, the electrons of oxygen, or the neutrons of oxygen. So atoms are made up of protons, electrons, and neutrons. The number of protons, which is, we use the letter Z to represent that, is known as the atomic number. The number of protons is the atomic number, and that number is on the periodic table. Protons are positive, electrons are negative, and neutrons are neutral. Atoms, then, are electrically neutral. The number of protons, or positive charges, is equal to the number of electrons, or negative charges. Being neutral refers to the electron charge and does not determine if an electron is stable. Now, if you see in my PowerPoint a negative E, that means electron. That's my symbol for electron. So again, atoms, they're all electrically neutral. They're not all stable, but they are neutral because the number of protons is equal to the number of electrons. The number of positives is equal to the number of negatives. The number of protons in an atom is equal to the number of electrons. That's why it's electrically neutral. Protons and neutrons are found in the nucleus or in the middle of the atom. They're together hanging out. The electrons surround the nucleus at various energy levels known as shells or orbitals. So the electrons float around the outside and the protons and neutrons get to hang out together in the middle. Most of the mass of the atom comes from that nucleus because that's where the protons and neutrons are. The electrons, their mass is so small we don't even include it. Atoms want to be stable. They want to be happy, and in order to become stable, they must either gain, lose, or share electrons. Being stable means it has 8 electrons in its outer shell. So all these atoms out there, all the elements, they're trying to become stable, and in doing so, that's what causes chemical reactions. The outer shell electrons are the ones that get to react. They're hanging out in the very outside. So they get to do the reaction, they get to move around and do what they need to do so that the atom can become stable. Outer shell electrons determine the reactivity of an atom. The most you could ever have in the outer shell is 8 electrons. The inner shell can have a lot more than 8 electrons, but the outer shell, the most it can ever have is 8. So 8 is the happy number, 8 electrons, outer shell. Gaining or losing electrons will cause that atom to have a charge. When this happens, the atom is known as an ion. So an ion is an atom with a charge. Well, think about it. If you had an element, and let's say it had 7 protons and 7 electrons, so it's a positive 7, negative 7, okay, and it wants to gain some electrons, it is gaining negatives. Let's say it will gain 1 electron. It's going to gain a negative, like gaining a negative friend, so it's going to have a charge of -1. If we have something out there, let's say that has 3 electrons, and it's going to lose all 3 electrons, it's going to lose negatives, just like losing a negative friend, you become positive, that atom would have a charge of +3. So when you lose or gain negatives, you're going to get a charge. Whether it's a positive charge or a negative charge, you get charged. And an atom with a charge is known as an ion. Here's my example. Chlorine, its atomic number is 17, so that means it has 17 protons. The number of protons is equal to the number of electrons, so there are 17 electrons. Again, chemically neutral, electrically neutral, +17, -17, that's 0, so it's neutral, but it sure is not stable. Because chlorine has 7 electrons in its outer shell, 7 is not 8, it is not happy. So chlorine has 7 electrons in its outer shell, it needs 8 to be happy, so chlorine will gain 1 electron. Chlorine will then become an ion that has a charge of -1. It's gaining a negative. If you gain a negative friend, you become a negative person. Just like these atoms, it gains one negative, it's -1. If it would gain two negative, -2. If it gains three negatives, -3. Very sad if you have to gain 3 negative friends. I did put the periodic table in here if you need to refer back to this, but you should have your own periodic table. I did want you to take a look at this. When we look at families, family 1A, don't look at the number, look at the Roman number. 2A, we jump over here to 3A, 4A, 5A, 6A, 7A, 8A. Those are the A families. Your periodic table, you need to write that at the top of your periodic table because I'm pretty sure yours does not have that. They're not numbered that way. We do not want to look at the numbers 1 through 18. We want to look at the Roman numbers. And then we have the transitional elements, which is 3B, 4B, 5B, 6B, 7B. This group here is all 8B, and then 1B and 2B. So again, make sure your periodic table is numbered like that. All periodic tables will have a place to look to see what the numbers all represent. So you can see atomic mass. You can see on here the atomic number. So we were talking about chlorine earlier. The atomic number for chlorine was 17. Atomic number of lithium is 3. The atomic number for calcium is 20. The atomic number is the number of protons, which is equal to the number of electrons. So calcium has 20 protons. Calcium also has 20 electrons. One nice thing about the A family, 1A, 2A, 3A, all the way to 8A, the family number lets you know how many outer shell electrons there are. Those are the important electrons. Those are the ones that get to react. So if you're in family 1A, you have 1 electron in the outer shell. 2A, 2 electrons in the outer shell. 3A, 3 in the outer shell. 7A, 7 in the outer shell. 8A, 8 in the outer shell. And you may know the 8A family as the noble gases. They do not react. They have 8 electrons in their outer shell. They're happy. They don't have to react. They're already doing the happy dance. Okay, outer shell electrons determine an ion's charge because it would have to react. It determines reactivity. For the A family, the number of outer electrons can be found on the periodic table. I told you about that already. You look at the family number, and that is how many electrons are in that outer shell. If there's 3 or less in the outer shell, the atom is going to lose electrons and have a positive charge. 5 to 7 in the outer shell, the atom will gain electrons and get a negative charge. Okay. So we have some symbols there which represent our elements. Let's go ahead and get the charges of these elements. So we have K, which is potassium. If you find that on your periodic table, potassium is in family 1A. It has 1 electron in its outer shell. 1 electron in its outer shell. It wants to lose. It's trying to get to 8. It wouldn't gain 7. That takes too much energy. So it's just going to lose the 1 it has. It's going to lose a negative. So it's going to become a positive 1 because it had 1 in the outer shell. Find calcium on your periodic table. Calcium is in family 2A, so it has 2 electrons in the outer shell. Now calcium has a total of 20 electrons, but in its outer shell, in that outermost layer, there's only 2. It's not happy. It's trying to get to 8, and it would take too much energy to gain 6, so it loses 2 electrons. Electrons are negative. It's getting rid of 2 of its negative friends, and is going to become a positive person by 2. So plus 2. That is iodine. That's an I there. Iodine is in family 7A. It has 7 electrons in its outer shell. It's not happy. So it's going to want to gain 1. It's not going to lose 7. That would take too much energy. So it's going to gain electrons, and it's going to gain a negative. Electrons are negative, so it's gaining a negative friend only by 1. So it's becoming -1. N is nitrogen, which is in family 5A. 5 electrons in the outer shell. It's too hard to lose 5. It's a lot easier to get to 8 by gaining 3 electrons. It's gaining 3 negatives, -3. Helium is in family 8. It has 8 electrons in its outer shell. You should know now that that's the happy. It's not going to gain any. It's not going to lose or gain electrons. It's already where it needs to be, so it's not going to have a charge at all. Okay, so there's that. If you have questions about that, please come and see me. I can give you more practice on that. Elements from the left side of the periodic table and from the right side of the periodic table will form ionic bonds. So if you're hanging out on the left and right side, they come together and will form ionic bonds, which then form what's known as ionic compounds. If you take calcium, it has 2 electrons in its outer shell. It's going to lose 2 and become a +2. Chlorine has 7 in its outer shell. It's going to gain 1 electron. It's gaining the negative to become -1. Okay, if we have calcium and chlorine coming together to make calcium chloride, that's an ionic compound. Calcium is from the right, chlorine's from the left. They transfer electrons. Electrons are being transferred, and there's charges going on. Calcium gets the +2, chlorine gets the -1. They come together, and now they're happy. And we're still neutral. We're electronically neutral, but they just switch things up a little bit so that they can be happy. Just because you're neutral does not mean you're stable and happy. But once they react, they're now both neutral and they're stable and they're happy. What happens is the charges swap elements and then they become subscripts. I'll show you another example here with sodium and oxygen. Okay, so sodium is in family 1A. It has 1 electron in its outer shell. It's going to lose the 1. It's going to lose a negative by 1. So it will have a -1 charge. Oxygen is in family 6A. It wants to gain 2. It's too hard to get rid of 6. It's just easier. Let's just gain 2 electrons. It's going to gain 2 negatives. So it's going to, that should be a positive. I'm going to clear that out. That's a +1. Sodium lost an electron, it lost, so it became positive. Oxygen wants to gain electrons. It's going to gain negatives, and it's going to gain by 2. So sodium and oxygen together become sodium oxide. You can see that the numbers just swapped places. Aluminum and sulfur. Aluminum has a charge of +3. It has 3 electrons in its outer shell. It's a lot easier to get rid of 3 than trying to gain 5. So it gets rid of 3 electrons, it's getting rid of 3 negative friends, and so it's becoming +3. Sulfur is in family 6A. It's not happy. It has 6 electrons in its outer shell. It's going to gain 2. It's not going to lose 6. That takes too much time. It's going to gain 2 electrons. It's going to gain 2 negative friends. And so it will have a charge of -2. The charges swap places. So then we have Al2S3. Al2S3, it's known as aluminum sulfide. Right now the important thing is where those numbers are coming from. And we'll practice some more of that in the classroom. There's the periodic table again. Okay. The mass number is the number of protons plus neutrons. There are isotopes. An isotope is an atom of the same element that differ in mass number. Same number of protons, different in the number of neutrons. There's some examples there. Protons and neutrons are equal in mass, make up the most of the mass of an atom. Electrons' mass is very small. It's not even calculated, it's so small. So the atomic mass is the average mass of all isotopes of an atom. The average atomic mass or atomic weight. And here's some practice problems. which I'll have the answers on another video.